Hi guys, in this video we're going to be talking about the product rule. Now the product rule is a differentiation rule that we use when we have, well, the product, surprise surprise, of two things. Now product is just a posh word for multiply or times. So you have two things that are being times together and we want to differentiate them. So for example, we might have x squared multiplied by sine x. Or maybe we have log x multiplied by e to the 3x. Or perhaps we have x squared plus 5 multiplied by cos of 4x. It could be any of these things. In all of these instances, we have two functions that we can individually differentiate, and the combination of those functions can be differentiated with the product rule. Okay, so what is the product rule? So if you have two functions multiplied together, I'm going to call them u and v. And I want to differentiate it. The product rule says that the differential of u times v is u times dv dx plus v times du dx. We'll have a look at a few examples of this in the next part of the video. Okay, so here is example 1. We're going to try and use the product rule to differentiate x squared multiplied by log x. And I'm just going to highlight the individual parts here, x squared and log x, separately, just so I can see what my u and v should be. Let's write these down. Now, it doesn't actually matter which way you put these. I'm just setting it up in the same order that was given in the question. So these are my two functions. What I'm going to do initially is just work out du and dv. So I'm going to work out the two individual derivatives. If I differentiate x squared, I should get 2x. And if I differentiate ln, I should get 1 over x. All right, cool. That's all going to plan so far. Now, the product rule says that if I want to differentiate the product of these things, it'll work out as u dv plus v du. So u dv is this thing multiplied by that thing. There's those two. And then v du is v times du. And my shape here is a little bit wonky, but it is a cross. It's a multiplication symbol. It's a time. So it reinforces the idea that the product rule is used when you have the product or the multiplication of two different functions. Let's just chuck all this together. So I've got u, which is x squared. I'll write that in green, times dv, which is 1 over x, plus v times by du, which is 2x. So you can see there's an element of u in both parts. One's u, one's du, and you've got dv here, you've got v there. So it's a symmetrical situation. So it wouldn't matter if we put it the other way around. If there is any simplification we can do, we probably should. So specifically, I'm looking at this term here, x squared times 1 over x. I can cancel out one factor of x, and I can get, well, just x now. And more out of habit than anything else, this isn't wrong, log x, 2x, but I'd like to put the 2x in front. And there's my derivative. Here is a second example using the product rule. This time we have a slightly more complicated function. We've got y equals 5x plus 3 squared multiplied by sine 4x. So let's just emphasize these two parts. We've got two functions. 5x plus 3 squared is one of them. Sine 4x is the other. Just going to jot those down as u and v. And because I've got something slightly different in the brackets, I will have to use the chain rule in both cases here. If you haven't looked at the PowerPoint discussing the shortcuts for how you can differentiate these quickly, I'd recommend going back to that. I will be using the shortcuts here. So this one, I can bring the power down, take one off the power, and multiply by the derivative of what's in the bracket here. So 5x plus 3 would differentiate to 5. And let's just tidy that up. I've got a 2 here, I've got a 5 there. I can write that as 10 lots of 5x plus 3. And we could expand it, but there's no need really, it's fine. As for the other function, sine 4x, sine differentiates to cos. And the chain rule says that I should multiply by the derivative of 4x. So I'm going to multiply by 4. And dv is going to work out as 4 cos of 4x. So I've got my expressions here. I've got u, du, and I've got v and dv. Product rule once again says that differentiating the product of uv is going to work out as u dv plus v du. So I'm going to times these things, and I'm going to times these things, and I'm going to get this. So 5x plus 3 squared, that's u, times by dv, which is 4 cos of 4x. Ooh, I wonder if I'm going to fit this in. Plus, yeah, this is going to be tight, 10 lots of 5x plus 3 times, it's not going to fit. All right, no problems. Let's just move that down a bit. Come down here. Where were we? That was u. That was du. We need to times it by v. Sine 4x. All right, cool. One thing I've done here actually is I've written this the wrong way round. It doesn't really matter. It is a symmetrical situation. So I've written down v du, I've written du, then multiplied by v. It's going to work out the same. Let's just tidy this up where we can. So I'll bring the 4 that's here in front. And I think this bit is okay as it is. And there's my derivative. Great. If you did want to tidy it up a little bit more, and some questions you'll be required to do this, there is actually a common factor here of 5x plus 3. So I could take that out if I wanted to. I don't think that it makes it look any nicer in this case, so we probably wouldn't bother, but since I've mentioned it, you could express the expression like this if you wanted to. And I guess you could even take it a little bit further, because 4 and 10 share a common factor 2. They share a common factor of 2. So I could take a factor of 2 out 4 divided by 2 is 2. Great. So sometimes that's useful. In this particular case, it hasn't really helped, but factorizing is generally a good habit to get into with differentiation.